Jeśli zastanawialiście się, czy opony w przyszłości będą w dalszym ciągu wymagać powietrza i czy być może będą mogły kontaktować się z pojazdem lub też między sobą, to dzisiaj w tym odcinku pokażemy Wam, jakie technologie zamierza Goodyear zaimplementować do swoich produktów. My znajdujemy się w Luksemburgu, w Centrum Innowacji, gdzie pokażemy Wam wszystkie najnowsze technologie, które będą w przyszłości dostępne w oponach. Zanim jednak pokażemy Wam opony z przyszłości, zwróćcie uwagę, to tutaj za mną znajduje się Eagle F1 Asymmetric 6. generacji. To właśnie tutaj w Centrum Innowacji powstały wszystkie technologie, które możemy znaleźć w tej oponie i to dzięki tym technologiom ta opona się tak świetnie prowadzi i wygrywa we wszystkich testach w tym roku. Przyznacie, że wyglądają te opony futurystycznie. Są to opony przyszłości, są to opony, które nie wymagają powietrza, by móc się na nich poruszać i to właśnie te produkty Goodyear rozwija, by wesprzeć samochody autonomiczne. Jestem ciekaw, jak na tej oponie będzie poruszać się samochód osobowy. Przetestujemy je dzisiaj na Tesli, na torze, który znajduje się tutaj obok Centrum Innowacji, więc oglądajcie do końca, bo będzie na pewno dużo nowości, a wydaje mi się, że produkt jest niesamowity. Projekt, który możecie zobaczyć za mną, czyli tak na dobrą sprawę latająca opona, która pozwala wzbić się w powietrze naszym samochodem. Mieliśmy okazję zobaczyć już w 2019 roku na targach w Genewie. Z tego, co się aktualnie dowiedziałem, projekt jest tymczasowo wstrzymany. Z tego też względu, że Goodyear teraz postawił na dopracowanie projektu opony niepneumatycznej oraz opon, które mogą komunikować się z pojazdem i tym samym zwiększyć nasze bezpieczeństwo podczas poruszania się po drogach. Koło mnie znajduje się Golf 8. generacji i wydaje mi się, że ten samochód najlepiej pokazuje nam, jak zmieniła się motoryzacja na przestrzeni lat. Pierwsze modele tego samochodu były bardzo analogowe, aż po 8. generację, gdzie aż wręcz roi się od wszelkiego rodzaju systemów, które mają za zadanie wspierać kierowcę podczas jazdy tym samochodem. I ze względu właśnie na te systemy zostały postawione nowe wyzwania przed producentami opon i na te wyzwania Goodyear przygotował swoją odpowiedź. Jest to system Goodyear Sightline, którego zadaniem jest przekazywanie jak najwięcej informacji z opon do systemów, które znajdują się w samochodzie. Jeśli zastanawiacie się, jakie informacje można przesyłać z wnętrza opony do systemów, które znajdują się w samochodzie, to spieszę już tutaj z wyjaśnieniem. Nie mówimy o takich podstawowych parametrach jak ciśnienie, temperatura powietrza. Sensory, które są umieszczone w oponach, są na tyle zaawansowane, że jesteśmy w stanie wyliczyć, ile kilometrów jeszcze jesteśmy w stanie przejechać na danej oponie w naszym samochodzie. A nawet w czasie rzeczywistym obserwować, co się faktycznie dzieje z tą oponą i samochód, posiadając te informacje, jest w stanie dopasowywać swoje parametry, tak by jak najlepiej poruszać się na tych oponach. Więc ta integralność pomiędzy oponami a samochodem jest naprawdę na bardzo wysokim poziomie. Z tego też względu na przykład samochód jest w stanie wygenerować nam zdecydowanie większą przyczepność w chwili, gdy poruszamy się na mokrej nawierzchni, bo samochód dokładnie wie, co się dzieje z oponą w danych warunkach atmosferycznych. Zosia, where is the most value of the Goodyear Sightline for customers?
So for the end customer, we see huge value in everything that is the customer experience part. So when you are driving your car today, you see functions on the display. You probably also have your app that is related to your car. And we see huge potential to integrate tire-related insights into those systems in order to make the whole tire buying and maintaining process for customers easier. So imagine you want to exchange your tire, you need to exchange it. How do you do it? Normally you call your dealer. You're going there in your workshop, it's not ready, they don't have the right size, or you have to wait. So we want to have a more frictionless tire experience for the end customer.
Okay, and why did you start this project?
So actually, tire intelligence is not new in the automotive industry, but what we want to do today, and Goodyear has been working on tire intelligence for years already, But what we want to do today is to democratize tire intelligence, make it available to a large number of applications of different segments, from the end customer to fleets, to the automaker, to AV systems, and have everybody benefit from the huge insights we can get from tires.
Can you give me a date when we can buy Goodyear Sightline in Poland?
Oh wow, that's a tough question. We are actually already piloting with fleets, with light commercial fleets, so with cargo van fleets, also in Poland, by the way. I don't know if I'm allowed to say the name, but we have a pilot fleet in Poland that we are having our experience with. We foresee having the first minimum viable product in the market next year, so probably as well in Poland.
And for you, which benefit is the most important in Goodyear Sightline?
Oh, that's difficult. There are multiple benefits, right? But since we are experiencing here today what tire intelligence can do with autonomous vehicles, I will focus on this. Obviously, this is a little bit further out in the future, but there the huge benefit is to inform the system of the vehicle itself, to make the vehicles safer and the roads safer, so to enable that autonomous future that we are looking at today.
Sounds great. I'm really curious how it works in real life, so we must take it on the road and drive.
Yeah, have fun during the demo, and thank you very much.
Thank you. Znajdujemy się teraz w Golfie 7. generacji i możemy teraz właśnie przekonać się, jak system Goodyear Sightline działa w rzeczywistości. Ja dostałem tablet, na którym mam przegląd wszystkich najważniejszych informacji, które jesteśmy w stanie pozyskać z czujników, które znajdują się w każdej z opon w tym samochodzie. I teraz właśnie tutaj z inżynierami Goodyeara wykonamy jazdę testową, podczas której opowiedzą nam trochę o tym, jakie parametry jesteśmy w stanie odczytać z tego systemu.
I'll use this monitor as well to show you through some of the values that we get to see from our real-time models that are running here. So as you see, we're driving here. We see the temperature on each tire, a bit more in the front than the rear, obviously, because we've been doing already some braking maneuvers. You see the pressure as well from our tire sensors. And as we're driving up to the test rack, I can show you the load, for example, here as well. So as I've just explained, so the sensors are able to measure the load that is on each tire, which is quite a unique feature nowadays, right? Because in some production vehicles you will already get some load sensing capabilities, but they're mainly just for front or rear axles, let's say on an axle basis. Now with the sensors we're able to split also between left and right, which is quite an important feature for commercial vehicles, like trucks, for example, that are heavily loaded. It is good to know whether the vehicle has been loaded in a balanced way, or if there's more load left to right, for example. So as we're driving, you'll see that the amount of data that's coming in from the sensor will increase. The samples are getting up, and we're getting some updated values based on that as well. We start with the surface state detection algorithm, which is an algorithm that is using the signals from the vehicle. And for this demo, we've been training it on smooth surface and rough surfaces. So it's important for us to know as tire intelligence team on which surface that your tire is driving, or that it has been driving for the past kilometers, to give a better performance of our algorithms. Because as you can imagine, a smooth surface has obviously a different reaction to the tire than a rough surface, right? So with this algorithm, we're looking at the energy level that is accumulated on the tires, and if it's above a certain threshold, the surface state will change from good to deteriorated. So as we've been driving here now on the smooth lane, you see that it's detecting good as a surface state, and this is actually, as you can see, the ideal case in terms of a road, right? So we're driving here on the uneven road, see that energy level going up, and the model is picking it up immediately as a deteriorated route. Also important for autonomous vehicles, right? If you want to do some change of driving lane, for example, if you want to be preferably on smooth roads, you could adapt your driving trajectory based on that. We'll do some 1 kilometer of dynamic driving now, and you'll see those values changing. So both the driving severity will go up, right? Because we're driving, let's say from a tire point of view, more severe, and the tire will be wearing faster, so the remaining mileage will be lower. So again, the model has been trained for this vehicle and for this tire. We get a good indication of which mileage will still be available out of that tire when you would continue driving like this for multiple kilometers. All right, so now we move over to the grip potential demo. We're going to do some braking first. So we have multiple models actually to estimate grip. So for grip, what we mean here is actually the maximum deceleration that you can expect on this tire with this vehicle.
How it calculate the grip?
So the grip, yeah, so it's actually what we're doing now for this model. So these models have been trained for this tire and this vehicle, right? So with this current condition on this asphalt, with the good weather today, the estimated value is at 1.1, all right? So that's the maximum deceleration that we can get if we do braking. And we have...
What is the metrics of the grip?
Well, the grip is actually, yeah, let's say that mu value here is actually the maximum deceleration that you can get. So the maximum braking force that you can get out of the tire.
Okay.
And obviously it changes on each tire, each vehicle. And again, it differs whether the surface is dry or wet. Okay, so after the, I would say the darker asphalt there, Robbie will do an ABS brake. So have a look at the values there. Keep yourself steady, because you're going to brake just after the darker asphalt. Okay. So if you look at the curves here, you can see that the estimated value that we had, they are aligning well with the maximum deceleration that we get on the vehicle. Again, important to give that value to your control systems, right? For certainly this kind of safety braking events. So again, you see the measured deceleration. It fits well with the estimated value. You can see the difference, right, between dry and wet. So again, important to have this such an input to your vehicle, because the vehicle can change the control system settings based on that input on that tire. So that's one way.
And how big is delay between sensor and what we see on the screen when it measure on the dry? Or
yeah, I would say the delay here is very small, right? It's just a few milliseconds, right? So it picks it up pretty quickly with the current setup of the vehicle. Obviously, it also depends on what we would have available on production vehicles in the future, right? So there could be some requirements. That's why we have a second model. I can show you that as well. So this is a grip potential which is mainly based on, let's say, a lot of testing data. Now we have also a model that is using the slip. So that's actually using the real-time signals of the wheel speeds. And we're also able to pick up, let's say, what is the grip potential there, based on actually the reaction of the wheels on the road.
Powiem Wam, że nie spodziewałem się, że ta technologia zrobi na mnie aż takie wrażenie. Miałem okazję być na kilku innych prezentacjach konkurencyjnych producentów, jednak tamte rozwiązania nie zbierały aż tak szczegółowych danych i przede wszystkim tamte dane nie były aż tak użytkowe dla kierowcy. Weźmy sobie pod uwagę przyczepność, którą bada sensor umieszczony w oponie. Te dane są przekazywane do systemów ABS. ABS lepiej działa, tym samym zwiększa się nasze bezpieczeństwo naszej rodziny. Jeśli jesteśmy pasjonatem motoryzacji, jeździmy na tor, możemy obserwować, jak zmienia się przyczepność tej opony. Czy to jest moment, kiedy powinniśmy odpuścić w zakręcie, dać chwilę odpocząć opony, czy może właśnie jest ona teraz przygotowana na maksymalny performance. Naprawdę ciekawe rozwiązanie, nie tylko dla kierowców, ale także dla firm, które chcą oszczędzać na transporcie, chcą pokonywać jak najwięcej kilometrów na oponach, które mają umieszczone w swoich samochodach. Jestem naprawdę pod wrażeniem i czekam, kiedy to rozwiązanie będzie faktycznie dostępne w Polsce i kiedy będziemy mogli je kupić i zamontować w swoich samochodach. To, co też ważne, to ten czujnik możemy zamontować w dowolnej oponie. Nie musimy kupować dedykowanych opon, które mają odpowiednie miejsca, gdzie ten czujnik musi zostać umieszczony. Goodyear pracuje nad tym, by guma, która trzyma ten czujnik, mogła być montowana przez każdego wulkanizatora w każdym kraju. Okay, Canva, could you tell me what is the most difficult thing in this system for you, for us?
Yeah, so today on display, as we've shown, we are doing real-time tire road friction or grip estimation. That's a complicated problem because the grip of a tire depends on the weather conditions, the road conditions, the health of the tire. So the biggest challenge for us was developing an intelligent enough algorithm that's able to account for all of these factors and still give reliable estimates of the grip potential of the tire.
Your colleague told me that delay between sensor and system is quite small.
Yeah, typically, you know, with the sensors we get data every 5 seconds. So every 5 seconds we are getting a new transmission, a new piece of data packet, and we then process that. The processing time, of course, is in milliseconds. It's a very small amount of time, but yes, it's about a 5-second delay.
Can I put this sensor to the all of the tire?
Yes, the algorithms we've written actually would also work on any other tire brand. So the way the algorithms are written are they're looking at certain tire properties which we can measure on any other tire brand as well. Yes, that's correct.
And can I put it inside the tire by myself?
Well, generally we recommend that this is done by an authorized dealership because the placement of the sensor on the tire is very important, where the sensor gets placed inside the tire. So at least for now, we generally recommend that this is done by a qualified technician.
And what about the balance of the tire when we have a sensor inside?
The sensor in the tire actually is a very lightweight sensor. It weighs less than 10 grams. So that will make sure that there's no issues with tire imbalance. It's an extremely small sensor as you see it and very lightweight.
And now you are using the data from the sensor from testing to develop a new tire like Goodyear Eagle F1 Asymmetric 6?
Yes, so there are multiple use cases, of course. You know, the intent is to have an intelligent tire in the market. But a lot of the data we are gathering during the development phase is also being used to improve the performance of our current product lines, yes. There's a very interesting information we gather about the tire performance over its life under different weather conditions, different operating conditions. All of that information does feed back into our R&D pipeline.
And how many receivers we have inside the car?
Actually, for the tire sensors, there's only one box. There's one
Can you
receiver.
show us?
Yeah, absolutely. So in the trunk, you will see a lot of electronics, but the box here, which is the silver colored box, is the box which is actually collecting all the data. Everything else is to control the brake system on the car. But that's the box where the information actually flows in, and that's where we run all the different algorithms. And once there's an output available, that output is then fed into the controller, which is all the other equipment you see here.
It looks very interesting. Nice to meet you, and I'm really happy that I can drive the car with this system.
Thank you, and thanks for being here on the track today. It's been an exciting day to spend time with the journalist team. So thank you again. I hope you enjoyed the demo day.
Thank you for.
Thank you.
Jak wyglądają opony przyszłości? Zobaczcie sami. Konkurencyjnych producentów. Ja p***ę. Dobra, jedziemy. Dawaj, Dawid, spina w Aż się popatrzyły. Nie, czekaj chwilę, bo jest beka. Dobra, jedziemy?